In this video, I am going to discuss about Richard Suchman's inquiry training model. The inquiry training model was developed by Richard Suchman in the 1960s. His aim was to teach students how to think and inquiry like scientists, that is, asking questions, forming hypotheses, testing ideas, and drawing conclusions. Suchman believed that students learn best when they are actively engaged in exploring problems, not just receiving ready-made information from the teacher. This approach helps students develop critical thinking, logical reasoning, and problem-solving skills. Now, the key features of inquiry training models are: it follows a scientific process of inquiry. The teacher presents a problem situation that the students are not familiar with. Students then try to gather data by asking questions. Teacher responds only with yes or no, no explanations. Students form hypotheses and test them. It proceeds through 5 phases. It's a student-centered approach but teacher-guided. Now, the structure of inquiry training model. The first one is syntax. First, encounter the problem. Second, data gathering, verification, then experimenting, then organizing and explaining the data, and analyzing the inquiry process. In social system, at the start, the teacher takes the lead by presenting a puzzle. After that, the classroom becomes a space for shared learning. Students work together, think freely, and are treated as equals. Teacher helps by guiding them to use resources, do experiments, and take part in meaningful discussions. Third, principles of reaction. The teacher asks clear, that is yes/no questions and encourage students to ask specific ones. Students are guided to focus on object, event, and proper questioning. They are encouraged to experiment, rephrase unclear questions, and interact with each other. All questions and answers are written on the board. Students' questions are not judged. Keeping the environment open, teacher helps students review the process to stay on track. The support system includes surprising events, materials that challenge thinking, good speaking skills, and the teacher's strong understanding of inquiry strategies. Now, the example of inquiry training model from the field of mathematics from class 8. Suppose a teacher wants to exploring the concept of sum of angles in a triangle. The first phase, that is encounter the problem situation, is the teacher draws several different triangles on the board: a scalene, an isosceles, and a right angle triangle. Teacher says each of these triangles has different shapes and size, but they all share something in common related to their angles. Try to find out what it is. Step 2, data gathering, that is verification. Students begin asking questions like, do all triangles have 3 angles? Teacher said yes. Are the angles always equal? Teacher said no. Can any angle be more than 90 degrees? Teacher says yes. The case of obtuse triangles. They are trying to collect facts by verifying basic properties. The third phase is experimenting. Now, students try to test their ideas. Each student measures the 3 angles of triangles they drew on paper using a protractor and adds them up. They share their finding. Triangle 1, 60 plus 70 plus 50 equal to 180. Triangle 2, 90 degree 45 45 equal to 180. Triangle 3, that is 100 plus 40 degree equal to 180 degree. Now they begin to notice a pattern. Now, the fourth phase is organizing and explaining the data. Now the student discuss all our triangles, no matter the type, have angles that add up to 180 degrees. It must be a rule that the sum of the angles of any triangle is 180 degrees. They form a generalization based on their inquiry. Teacher finally confirms, yes, any triangle, the sum of the 3 interior angles is always 180 degrees. Now phase 5, that is analyzing the inquiry process. Teacher now leads a reflection session. What strategies did you use to find the answer? Did you work together or test on your own? Did your prediction match your result? Students analyze how they learn, not just what they learned. The inquiry training model encourages active learning, develops scientific thinking, builds confidence in exploring mathematical ideas, promotes collaborative learning, etc. Now try this.